Proceedings of the International Symposium on New Energy, Denver, Colorado, USA, May 12th to 15th, 1994. Overunity, electrical power efficiency using energy shuttling between two circuits by T.E. Bearden, M.S. Abstract. To enable an electrical power source to power a load with overunity efficiency, a two-circuit, two-cycle energy shuttle methodology is utilized. In the first cycle, a capacitor collector is charged from the source without entropy and without source depletion by use of a stair-step ramp-up application of the source voltage, utilizing several hundred small rectangular steps. In cycle 2, the charged capacitor is disconnected from the source and shuttled to a separate load circuit and discharges through the load to power it. Nearly free power is thus obtained in the load without appreciable depletion of the primary source except to power the switching and miscellaneous losses. The two-cycle energy shuttle process is iterated, providing a heat pump-like operation and permissible overunity operational efficiency. The excess energy is extracted directly from the vacuum via the Stone/Whittaker/Ziolkowski bidirectional EM wave flow exchange between the vacuum and the bipolar separation of charges in the source. The source is utilized primarily as a receiving antenna for this vacuum-to-source free EM wave exchange, which constitutes the potential gradient between the source's terminals. Some practical problems with the circuitry are briefly discussed, including internal movement of capacitor plates and dielectric, nonlinear optical functioning of solid-state switching components at ELF frequencies, and lack of any known instrument to differentiate between displacement current d phi over dt and normal current I equals dq over dt. Introduction. The present paper is essentially an update to The Final Secret of Free Energy, published in the Proceedings for the First International Symposium on New Energy in 1993. It is assumed that the reader is familiar with the content of that paper. My associates and I have filed our first patent application on two electrical overunity processes and devices, one similar to what is outlined in The Final Secret of Free Energy, and an additional variation utilizing collectors that are standard step-charge capacitors rather than degenerate semiconductor materials. Figure 1. Extracting and utilizing free electrical energy from the vacuum via the internal wave energy flow exchange hidden inside the potential gradient across the source's terminals. Figure 2. Type circuit for single-pulse charging of a degenerate semiconductor collector without appreciable work, and separate discharge of the collected energy in the load without substantial depletion of the primary source. Circuit design by Steve Patrick. Use of a degenerate semiconductor collector. In the first paper, we utilized a degenerate semiconductor material for the collector, such that the material possessed an extended electron gas relaxation time, sufficient to allow electrostatic potentialization of the electrons in the collector material and switching of the electrostatically charged collector separately across the load prior to relaxation. Subsequently, electron gas collectors trapped electrons with their excess energy to be discharged separately through the load. Figure 1 shows the schema used for the charging/collection and switching/discharging cycles. Figure 2 shows the typical arrangement we have used in many of our experiments on this approach. For the degenerative semiconductor material, an alloy of 2% iron and 98% aluminum has been uncovered that will provide the proper extended relaxation time. However, because of different melt temperatures and other phenomena, the alloy is very difficult to manufacture. Only 1 or 2 potential manufacturers will even attempt it, and then only if precise quantities are purchased. Consequently, this solution is not practical at this stage of research and development. Presently, we are continuing our search for more practical degenerate semiconductor material and are confident that a more suitable material will eventually be found. Present status. Meanwhile, we have sharply focused our present work upon the known fact that a capacitor can be specially charged essentially by utilizing voltage with little or no electron current, i.e., the well-known simple formula for the energy in a charged capacitor is simply 1/2 CV squared. For a given ideal capacitor, C is fixed, and therefore its charge up with energy depends only upon impressing a potential gradient across it. The fact that a capacitor can be charged in this manner without work and without entropy is already proven in the literature. However, real capacitors have also proven to exhibit additional operational phenomena quite separate from capacitance. And these extraneous phenomena normally render overunity operation very difficult or impossible. Nonetheless, both the theory and the experimental proof already exist that a capacitor can collect energy from a source without work. Given that such free energy collection charging can be accomplished on a somewhat larger scale, then with our energy shuttling and switching approach, it rigorously follows that overunity electrical power operation is 1, permissible, and 2, practical. In this paper, we present our approach to step charging of capacitors and detail some of the unconventional circuit phenomena that result. We have identified 3 problems areas that must be solved before practical scaled-up overunity power systems using capacitor collectors can be developed. However, each of the solutions is a doable project, and so C-Tech effort is vigorously focused upon resolving these 3 problems, while we continue to research additional candidate materials for the degenerate semiconductor collector. Figure 3, extracting and utilizing free electrical energy from the vacuum via the internal wave energy flow exchange hidden inside the potential gradient across the source's terminals. Stair-step charging capacitor. Figure 4, type circuit for stair-step ramp-up charging of a rigid capacitor collector without appreciable work, and separate discharge of the collected energy in the load without substantial depletion of the primary source. Circuit design by Steve Patrick. Charging a capacitor without entropy and without doing work. Several scientists have previously pointed out that real capacitors can be charged without appreciable entropy. In our recent patent application, this is one of the methods utilized, along with judicious and efficient switching, to increase the coefficient of performance of selected power sources to greater than unity. The Figure 1 schema has been adapted to add multiple step charging of a capacitor, as shown in Figure 3. In this realization of the invention, a stair-step ramp charging of a capacitor is performed, utilizing several hundred consecutive rectangular voltage step-ups in the ramp. Figure 3 shows a schematic representation of the setup for the stair-step ramp-up of the impressed voltage. Figure 4 shows a typical type of ramp-up circuit designed by Steve Patrick and utilized in our experiments. A precision measurement resistor is utilized in series with the capacitor to allow measuring the current accurately. The duration of each step-up is determined by the time constant of the capacitor with the series measurement resistor. The capacitor is charged with massless displacement current. Essentially, the capacitor is charged with displacement current d phi over dt, so that the quantity E equals minus del phi across the capacitor's plates is increased by directly altering the magnitude of phi on the top plate without movement of electrons. As is well known, the flow of massless displacement current does not result in the production of heat, and hence no entropy is produced by it. This means that if the capacitor is charged with displacement current only, no electron current flow has been forced back up through the back EMF of the source. Hence, no work is done inside the source, and no dissipation of the source's dipolar separation of charges occurs. Figure 5 shows an isolated view of a primary battery source. If no return electron current dq over dt is passed back up internally through the battery against its back EMF, no work is done inside the insulated battery to dissipate its separation of charges. The amount of power that can be drawn from the battery/collector in the collector and used to power the load with work-free energy is obtained in the collector from a standard conventional source, in this case from a battery. The source is just a dipole antenna. During this energy collection phase, the source is utilized purely as a dipolar antenna to receive mass-free electrical energy density flow dFEI over dt from the vacuum and exchange dq over dt back to the vacuum. It has been shown by Stoney, Whitaker, Zielkowski, and his colleagues, and Sue that any scalar potential, including that between the terminals of an electrical power source, mathematically decomposes into hidden bidirectional EM wave pairs. Hence, the open circuit voltage, or del phi, between the terminals is a hidden EM wave energy flow process having a finite local energy density in the flow, but unlimited total energy throughout all space. So, a special form of EM energy density is continuously exchanged between the surrounding vacuum and the terminals via the hidden dynamic wave structure of the potential gradient. Figure 5. Internal return electron flow against the back EMF of the battery dissipates its internal separation of charges, thus dissipating the dipole antenna/receiver capability of the battery/source. Figure 6. The reason why all conventional two-wire closed-circuit electrical systems are under unity in operational efficiency, coefficient of performance. Action of the displacement current in the ideal capacitor. Massless displacement current dF over dt has the characteristic of coupling to any electric charge it meets, forming an E field upon that charge and thereby tending to move the charge. In a capacitor whose plates and dielectric are rigid, electron current cannot cross between the plates. Instead, the electrons are restrained in their movement. Therefore, the electrons in the plate receiving the displacement current have little or no movement. Consequently, d phi over dt flowing into that plate results in a steady d phi over dt onto the restrained electrons, increasing the magnitude of phi upon the electrons trapped in that plate, and hence steadily increasing the del phi existing between the two plates of the capacitor by the equation E equals minus del phi. There thus is steadily built up an increasing E field across the capacitor, charging it with electrical energy. In this idealized case, the capacitor has been charged with pure, lossless energy, transport only. This is one form of superconductivity. There are no power losses, hence no degradation of the source has been accomplished. The non-ideal case. Now we contrast this idealized case, where the capacitor is just a rigid capacitor and nothing else, with the real case in available practical components. For any appreciable capacitance, e.g. 300 to 1000 microfarad, no physical capacitor at normal bench working voltages is presently available that is rigid. Instead, the plates move, the dielectric moves, etc. The movement of one or more of the capacitor plates, as well as the movement of the dielectric between the plates, each constitutes a movement of trapped electron charges. Compared to the actual drift current movement of intercepted electrons, the circuit, this capacitor component movement current, is appreciable. The result is a reduction of the repulsion from the charging capacitor plates electrons back to the source's positive pole electrons. This allows additional electrons to be forced out of the battery's positive terminal. In turn, this allows the same number of electrons to be forced back up through the source against its back EMF, doing work inside the source to disperse the internal separation of charges. In this way, the capacitor's dynamic internal component movements have converted the collected free energy received from the displacement current d phi over dt into work by their physical movement. Further, for every coulomb of electrons that participated in this extremal circuit work, a coulomb of electrons participated in an equal amount of work performed inside the source to dissipate its separation of charges. Consequently, the free energy collection process is dissipated by movement of capacitor plates and dielectric. There really is a deep conspiracy to suppress free energy. Immediately, it can be seen that normal capacitors usable in power systems actually are systems whose internal dynamics are already designed, either intentionally or unintentionally, to prevent the collection and free use of EM energy from the source by transferring and collecting the displacement current alone. So also is the standard practice of using a two-wire closed circuit so that electrons have to be circulated, pumped around a closed circuit. We also state without further discussion that there exists decisive documentary proof that specific major agencies, researchers, and universities in both Russia and the United States developed practical Overunity electrical power devices in the early 1930s. This work was suppressed and many other actions were taken to prevent the further spread of free energy. Suicidal nature of the two-wire closed circuit. In the conventional closed two-wire circuit, when the free displacement current energy collected in the capacitor is discharged through the load, the ordinary electron current is driven through the load because the d phi over dt immediately couples to the electron gas in the circuit conductors, forming E fields and causing the electrons to move through the circuit. However, the current through the load is closed-looped to incompressibly flow back through the source against its back EMF. By Ampere's law, for each electron driven in this current through the load, an electron is also driven back through the source internally against the source's back EMF, expending work inside the source to disrupt its bipolar separation of charges. For each joule of collected free energy discharged in the load as work, a joule of it is also discharged inside the source to deplete its separation of charges. Consequently, there is no net power gain between power in the load compared to damage done to the source's bipolarity. Inevitably, at least some additional losses exist in the real external circuit as non-useful loads, and their currents also are routed back through the source's back EMF to produce additional work and destruction of the source's dipolarity on a one-for-one, joule-for-joule basis. This means that in the conventional two-wire closed circuit, even though free excess EM energy is continually received and collected in the collector/capacitor from the vacuum to source dipole energy exchange, the fraction of the free energy that is used to freely power the load is always less than the fraction of it that is used to internally deplete the source, i.e., to freely de-power the source. Standard electrical circuits are in fact suicide circuits guaranteed to use their already free energy extraction to kill the source antenna more than powering the load. Figure 6 shows this self-imposed conventional circuit limitation. Conventional circuits completely negate the Overunity electrical circuit implications of references 1 to 4. Suicide is not an inherent characteristic of the source. The conventional practice of circulating, pumping, all spent, ground return, currents from all external current loops back through the source against its back EMF is not an inherent characteristic of the source itself. It is simply what we have all been instructed to do for over a century when connecting sources for powering loads. It guarantees under-unity coefficient of performance for all current electrical power systems because of their utilization method. It guarantees that the power meter stays firmly on one's home, the power company continues to consume large quantities of fuel, and the gas meter stays firmly on the gas pump when one refills the gas tank of one's automobile. It also guarantees a continuing pollution of the planet from combustion of fossil fuels and radioactive wastes from nuclear power plants. Breaking the suicide circuit. In the proposed invention, we have broken with tradition and altered the standard two-wire closed circuit practice. With judicious switching, we utilize the collecting capacitor not only as an entropy-free energy collector, but also as an energy shuttle between two separate circuits, one of them the collection circuit without the load, and the other the load discharge circuit without the primary source. By ramp-up step charging of the capacitor, excess dF over dt energy density flow is freely collected in the collecting circuit. By ramp-up step charging, excess potential gradient energy density, V phi, joules per collecting coulomb, is collected without entropy upon Q coulombs of free electrical charge contained in the rigid plates and constrained by the dielectric. Once charged, the capacitor is then shuttled away and connected to the discharge circuit to discharge normally through the load and furnish power. The load discharge current powers the load and also depletes the collector shuttle, but it does not deplete the primary source since it does not pass through it. The currents in the two circuits are entirely separated. The load discharge current does not perform any work inside the primary source to deplete its bipolarity, similar to a heat pump cycle. With efficient switching and energy shuttling, the source and circuit can exhibit a heat pump type cycle with over-unity coefficient of performance. Ideally, all that is taken from the source is massless displacement current, pure potential without electron current flow and without entropy. No electrical power is furnished to the load. When the shuttle capacitor has discharged, it is then switched away from the load and connected back to the ramp-up charging circuitry to be freely charged once again. We stress the exact analogy to a heat pump. Energy is extracted from an external free source, collected, then transported to the load and discharged as load work. As is well known, the thermodynamic coefficient of performance, operational efficiency, of an ideal heat pump is 8.22. For real home heat pumps under nominal conditions, an average efficiency is about 4.0. By mimicking the heat pump cycle, an electrical device thus should be capable of permissibly achieving over-unity coefficient of performance, operational efficiency. In the proposed process, we have attempted to do just that, mimic the heat pump cycle. By iterating the collection and discharge cycles, the load continually receives real, free electrical power. Ideally, the only source dissipating losses in the dual circuit system are for the switching overhead and for any other miscellaneous small line losses, etc. Additional capacitor shuttles can be added to a single source, and smoothing circuitry can also be added as needed into the load discharge circuit to smooth the delivered power. Over-unity operational efficiency, aka coefficient of performance. The operational efficiency, coefficient of performance of an electrical power system may be defined as the average power obtained in the load divided by the average power performing disrupting work inside the source to deplete it. For very efficient switching and good collectors, with this dual circuit collection discharge iteration, one can get more output power in the load than the depletion power performed inside the primary source. And the excess energy simply flows in from the vacuum onto the collector during the collection cycle. So in theory, one can permissibly produce an electrical power system with over-unity operational efficiency by adapting almost any primary power source and using it in a two-circuit system connected by an energy shuttling collector/discharger. All electrical power sources are already free energy sources. A novel postulate is now advanced. Every electrical power source is already a free energy source, freely extracting excess energy density, joules per collecting coulomb, from the vacuum and gating it to its terminals as a potential gradient, with equilibrium exchange flow back to the vacuum. It is the ubiquitous practices of 1, utilizing the two-wire closed circuit, and 2, utilizing electron current almost exclusively, that forces our power systems to operate at under-unity and dissipate themselves, consistent with the known laws of physics. We stress that the over-unity methodology being advanced does not violate the known laws of physics. The local conservation of energy for a closed system is permissibly violated because the system is open and not in equilibrium during the collection cycle. During that cycle, it receives excess EM energy influx from an external source, the vacuum, and stores it in the capacitor/collector. This is simply a special form of refueling. Global conservation of energy, of course, includes both the system and its external environment and is rigorously conserved. Numerous over-unity power systems are already known. The system is directly analogous to known over-unity open systems such as solar cell arrays, windmills, water wheels, and heat pumps. In these systems, excess energy is also extracted from a free-flowing energy source, transported without loss to a collector, then separately discharged through the load to power it. None of them violate the known laws of physics. Known over-unity systems already avoid closed system looping. It is also strongly emphasized that none of these permissible over-unity systems utilize a part of their inflowing collected energy to dissipate the source. For example, no windmill engineer would design a windmill such that when its angled blade assembly was rotated by the wind, a feedback gear arrangement would gradually rotate the individual blades until they were parallel to the wind direction, stopping the windmill and requiring that they were parallel to the wind upon it to reset the blades. Yet every two-wire electrical power system utilizes an analogous self-destructive feedback with a closed electron current system to constantly dissipate the source antenna and stop the free flow of energy from the vacuum. In fact, with the conventional system, the more work produced in the load and other external losses, the more work produced in the source to dissipate its free energy receiving dipolarity. The first and second laws of thermodynamics. The second law of classical thermodynamics does not forbid the new circuit usage because the system is an open system, not in thermodynamic equilibrium for a significant portion of the time. The second law is well known to be inapplicable to such systems because classical thermodynamics itself is inapplicable to them. Note that since classical thermodynamics does not apply locally to such systems, the conservation of energy law, which locally is just the first law of thermodynamics, also need not apply. In fact, rigorously, the thermodynamic first law statement of energy conservation with respect to such a device is, it is impossible to construct a machine which does work without obtaining energy from an external source. This law is not violated because the process does obtain energy from an external source prior to utilizing that energy to do work in powering the load. Objection to the theoretical possibility of over-unity electrical systems, based upon the grounds that they are prohibited by classical thermodynamics, is erroneous and merely reveals that the objector is poorly informed in physics and has assumed a closed system or an open system in thermodynamic equilibrium. Note that all our present fueled power systems are in fact open systems during the time of fuel loading, i.e., during the refueling time. These systems already collect excess trapped energy from an external source prior to powering the load. We point out, however, that both a first law and second law thermodynamics objection to any closed system or system in thermodynamic equilibrium purporting to produce over-unity efficiency without refueling from an external source is solidly founded and rigorously valid. Not a perpetual motion machine. The two-circuit energy shuttle system is also not in any fashion a perpetuum mobile in the understood isolated system sense. The well-known fallacy in the perpetual motion concept is based upon the grounds that they are expected to continually furnish excess energy output itself. The system is closed, no energy can exit or enter, hence no external load can be powered. If the system is a nearly closed system and almost in thermodynamic equilibrium, but just with some inevitable limited production of heat and external leakage, the normal case, the first and second laws of thermodynamics rather rigorously apply, and the system's operational efficiency will always be less than unity. If one questions whether an open system in a dynamic energy exchange with the environment can be in perpetual motion, the thermodynamics' physical universe are already that kind of perpetual motion due to their incessant energy exchange with their vacuum environment. These little engines that make our physical reality possible have been dynamically going for billions of years, and at present they show no signs at all of slowing down. Electrical energy can, in theory, be extracted from the vacuum. Extraction of electrical energy from the vacuum should not be regarded as mystical. A large number of physics papers already attest to the extraordinary amount of zero-point EM energy contained by the vacuum. Indeed, Cole and Puthoff have already shown that extraction of energy from the vacuum is in theory possible. Further, Puthoff has pointed out a cosmological feedback principle in the zero-point energy of vacuum, which constitutes a continual exchange of energy between any charged particle and the rest of the charged particles in the universe. New circuit phenomena must be mastered for over-unity operation. However, the stable functioning of most over-unity capable circuits is still very much a matter of contention. Over-unity operation is a highly nonlinear effect a priori. One meets unusual electrical circuit phenomena in attempting to perform over-unity electrical operations. For over-unity, a priori one must slip excess potential through the circuit essentially without losses. That is, One must deliberately pass massless displacement currents through the circuit, and at least through some of its components. Solid-state semiconductor switching components, in particular, exhibit unusual phenomena, to say the least, when excess potential is introduced into and through all their internal components. Our own group has had a common diode, not the light-emitting type, emit a flash beam of laser-like light each time it switched. In several other cases, two components entered into iterative pumped phase conjugate reflection, self-targeting, with each other, resulting in the rapid buildup of energy in them and blow-up of one or both of the components. In some components, the current sometimes ran backwards. An ordinary MOSFET may contain 25,000 separate internal components. It is as if someone crammed the entire electronic parts store inside it. Simple switches, these semiconductors are not, when exposed to massless displacement current. Often they simply self-destruct when faced with exposure to appreciable d-phi over dt passing through them. When one slips in some pure potential, by mathematical decomposition, one has also slipped in some bidirectional EM pump waves. The nonlinear semiconductor materials will function as phase conjugate mirrors when suitably pumped, including at non-optical frequencies. Consequently, pumped phase conjugate replica signals, self-targeting, ping-pong, direct beam-like exchange of energy between two or more semiconductors, formation of quantum potentials and modular variable effects sometimes begin to evidence. We will address and explain some of these effects in a future paper. For now, we simply state that they occur, and there is a host of new phenomenology that the experimenter may encounter in his circuits on the bench. However, an iron rule for the experimenter is that for odd circuit behavior, first exhaust all normal causes before turning to the extraordinary causes. One will save oneself a great deal of grief by applying this Occam's razor. One must understand nonlinear optics type functioning. Also, in deliberately utilizing displacement current, one is actually employing an expanded higher topology, EM, with additional degrees of freedom, similar to that pointed out by Barrett. Consequently, one encounters a host of additional higher topology EM phenomenology. In particular, one encounters nonlinear optical, NLO, functioning of the semiconductors at any and all frequencies, not just in optical bands. To clearly show that NLO analysis is a proper course of analytical action in a nonlinear material environment, Jackson points out that at frequencies below 10 to the power of 6 Hz. For common weak fields, it is fruitful to neglect ordinary spatial nonlinearities because it can reasonably be assumed that all charges, regardless of their inertia, respond to the applied fields in a linear manner. At stronger field strengths, nonlinear behavior results. In a highly nonlinear locality, such as in a semiconductor, the assumed linear behavior may be dramatically altered and may occur at much lower field strengths. The resulting behavior may be highly nonlinear and quite different from conventional electrodynamics prediction. Jackson specifically points out that nonlinear behavior of this sort has become a research area of its own called nonlinear optics, and also a laboratory tool. We point out that when Jackson wrote these prophetic words, nonlinear optics, as we know it today, was just in its infancy. It then being only some 3 years since Soviet researchers had briefed Lawrence Livermore National Laboratory scientists on their experimental discovery of an eerie, order-restoring EM wave, which today we know as a true time-reversed EM wave. Yet Baruch had theoretically discovered the time-reversed EM wave many decades before. Summary and conclusion. My associates and I regard the dipolar separation of charges in every electrical power source as already a free energy antenna dipole for receiving and extracting electrical energy from the vacuum. To the casual observer, the influx of hidden bidirectional energy exchange between the source dipole and the dipole is in the form of the potential envelope and represents excess energy density flow in terms of joules per collecting coulomb. If the collecting coulomb are free to move as ordinary electron current, their excess collected energy is constantly scattered as photons, heat, by electron collisions, producing work. In that case, the device will always operate at under-unity efficiency. Therefore, for overunity efficiency, the hidden energy density flow from the source must first be collected upon some resistor/collector, then provide a specific amount of collected stored joules of energy that have been collected without work entropy. The basic schema is simple. Gate some of that freely flowing potential energy density from the dipolar electrical power source to a capacitor/collector to provide a specific amount of collected stored joules of energy that have been collected without work/entropy. The basic schema is simply to gate some of that freely flowing potential energy density from the dipolar electrical power source to a collector as massless displacement current, where it impresses excess trapped energy without entropy upon the electrons already in the capacitor/collector. Then this collected excess energy is shuttled to the load in a second circuit, where the electrons and their excess energy are discharged through the load to separately power it without discharging back through the primary source to cause dissipation of the source antenna's dipolarity. We urge scientists, engineers, and interested parties to simply build such two-circuit entropy-free energy collection and shuttle devices and test them, and verifying or falsify the principle themselves. We also urge physics and electrical engineering teachers to assign construction and testing projects in such energy shuttle circuits to their students. The three remaining problems we at C-Tech must solve for our approach to overunity electrical power systems are: 1. A rigid capacitor with substantial capacitance and no internal component movement must be developed. 2. Stable state semiconductors must be identified or developed that will accept the passage of substantial d-phi over dt without instability. And 3, straightforward instruments must be developed for differentiating between displacement current and electron current, for measuring the displacement current. As we said, solutions to these problems are achievable. We are presently seeking grants and capitalization to more massively attack these problems and solve them quickly. Free energy and free energy sources are already ubiquitous but grossly misused and wasted. We firmly believe that it is time for the barbaric misuse and waste of energy and energy sources to stop, and for robust, clean, nearly free energy to be developed and utilized to power the machines and mechanisms of modern civilization. Only then will we have a truly civilized use of energy and resources and a clean environment for ourselves and future generations. Notes and references. Kalkin, M.G., and D. Kiang, 1983. Entropy, Change, and Reversibility, American Journal of Physics, Volume 51, pages 78 to 79. Gupta, V.K., Gaurishankar, and N.K. Sharma, 1984. Reversibility and Step Processes, An Experiment for the Undergraduate Laboratory, American Journal of Physics, Volume 52, pages 945 to 947. Heinrich F., 1986. Entropy Change When Charging a Capacitor, a Demonstration Experiment, American Journal of Physics, Volume 54, pages 742 to 744. Fundan I. C. Rees and H. H. Soonpa, 1992. Charging a Capacitor, American Journal of Physics, Volume 60, pages 1047 to 1048. Buchwald, Jed Z., 1985. From Maxwell to Microphysics, University of Chicago Press, Chicago, Illinois, page 44 provides a typical quoting: "No energy transformation into heat occurs for displacement currents." As is well known, in the vacuum there is only displacement current, since there are no free electrons to provide electron current. Indeed, this displacement component in the vacuum, associated with the electric field component, is responsible for continuously creating the magnetic field component of the electromagnetic wave, and accounts for the perfect phasing of the magnetic and electric field components. We point out that a copper wire, or metal plate, consists mostly of vacuum, rather than electrons and nuclei. In fact, the production of electron current in a conductor or a plate is due to the continual absorption of dF/dt by the free electrons in the electron's gas, and the resulting continual production of E fields upon them. We also point out that massless charge, which is after all just the self-potential of a charged particle, is not quantized. It is directly changed by adding coupling delphi. Hence, when an E field is created upon a charged particle, the fundamental electrical charge coupled to the particle's mass is changed. If massless charge could not be altered, then none of our electrical circuits would work, simply because there could never exist a delphi across an individual electron, and that electron therefore could never move as a part of the current. The existence of currents in electrical circuits rigorously falsifies the present physics notion of quantized charge, but no one seems to have previously noticed it. The magnitude of the scalar potential is a misleading concept. Rigorously, when one calculates the magnitude of a potential at a spatial point, one calculates the Coulombic energy collection density of the potential's bidirectional EM energy flow at that point should a coulomb of charged mass be made available there to collect the energy. For phi I equals n, 1 coulomb of point charged mass placed at that point will collect n joules of excess energy upon itself. Stoney, G.J., 1897. On a supposed proof of a theorem in wave motion, Philosophical Magazine, Volume 5, Number 43, pages 368 to 373. Whittaker, E.T., 1903. On the partial differential equations of mathematical physics, Mathematische Annalen, Volume 57, pages 333 to 355. In a second paper the next year, Whittaker pointed out that the classical electromagnetic field for electrons could be replaced by the interference of two scalar potentials, by the interference of their hidden multisets of paired EM waves. C. E. T. Whittaker, 1904. On an expression of the electromagnetic field due to electrons by means of two scalar potential functions. Proceedings of the London Mathematical Society, Series 2, Volume 1, pages 367 to 372. It may be argued that this paper implicitly anticipated the Bohm-Aronoff effect by more than 5 decades and extended it to distance-independent scalar interferometry production of EM fields at a distance, while modern experiments have only verified such in interferometry for a distance of a few angstroms. Scalar potential interferometry is not an oxymoron once one understands that the scalar potential consists totally of bidirectional EM wave pairs. Scalar interferometry of two or more scalar potentials thus becomes simply a special form of multi-wave interferometry in the initial absence of net force fields, net potential gradients, on the interfering potentials. Ziolkowski, Richard W., 1985. Exact solution of the wave equation with complex source locations, Journal of Mathematical Physics, Volume 26, pages 861 to 863. C. Also, Michael K. Tippett and Richard Ziolkowski, 1991. A bidirectional wave transformation of the cold plasma equations, Journal of Mathematical Physics, Volume 32, pages 488 to 492. Sue, C.W., 1993. A DC voltage is equivalent to two traveling waves on a lossless, non-uniform transmission line. IEE, Microwave and Guided Wave Letters, Volume 3, page 82. Ziolkowski, 1985, Ibid Imarn, page 862, clarifies the issue of the infinite energy. For that reason, when one connects n multiple sets of leads to the source terminals, the same potential gradient del phi, i.e. the open circuit voltage, appears between the two leads of each pair at their distant end instead of del phi divided by n. Essentially, one can treat the longitudinal electron flow down a conductor in a closed circuit as incompressible fluid flow. Thus, for every electron that moves off the positive terminal of the source and out into the external circuit, a return electron is driven into the negative terminal and up against the back EMF of the source. Begrudgingly, one must admit there was apparently some logical reason for the suppression. Violation of local energy conservation by a powerful free energy device can produce a local curvature of space-time, ST, in and around the operating device unless preventive measures are taken. This ST curvature alters the local rate of flow of time and thus affects all local operating things that exist in time. Note that the mind itself and the thoughts and memories therein also exist and function in time. These entities are therefore affected by the altered flow of time. Fairly powerful free energy devices, say of the power necessary for a medium factory, thus can produce detrimental biological effects, not only upon the physical body, but also directly in and upon the mind, memory, personality, and cognition. Unrestricted operation of the free energy device also gradually conditions and structures the local background potential upon the mass in the area and upon the local vacuum potential. These effects are much like charging a battery. They have a long discharge time once charged up. The persistent effects can conceivably be biologically harmful if proper care is not taken in the sustained operation of a substantial Overunity device. Qualitatively, we visualize the ambient, unperturbed electron gas in a conducting plate as existing with an equilibrium electron exchange between the metal lattice and the gas. For small changes of VF, reversible thermodynamic interaction holds. Here, small changes of VF can be applied without entropic net electron current flow. We consider this similar to the notion of static friction versus dynamic friction in mechanics. Static friction being much higher so that small perturbations do not result in electron translation even though above the dynamic friction resistance level, so long as the static friction resistance level is not exceeded. In a fluid analogy, a viscous region may be visualized to exist in the electron-gas exchange with the lattice for very small step-up changes, where each step-up is held constant for a period to allow readjustment of the electron exchange rate between lattice and electron gas. Halliday, David, and Robert Resnick, with assistance of John Merrill, 1988. Fundamentals of Physics, 3rd edition extended, John Wiley & Sons, New York, New York, page 518. Lindsay, Robert Bruce, and Henry Margenau, 1963. Foundations of Physics, Dover Publications, New York, New York, page 217, provides confirmation. The entropy for non-equilibrium conditions cannot be computed by classical thermodynamics, which can only state that the entropy of a system not in equilibrium must be greater than the entropy of the same system when it is closed and in equilibrium, since the equilibrium state is the state of maximum entropy. Use, Georg, with the collaboration of Ira M. Freeman, 1986. Theoretical Physics, 3rd edition, translation of Lehrbuch der Theoretischen Physik, Dover Publications, New York, New York, page 501. Aitchison, I. J. R., 1985. Nothing's Plenty, The Vacuum in Modern Quantum Theory, Contemporary Physics, Volume 26, pages 333 to 391, provides a good summary. Cole, Daniel C. and Harold E. Puthoff, 1993. Extracting Energy and Heat from the Vacuum. Physical Review E, Volume 48, pages 1562 to 1565. Puthoff, H. E., 1989. Source of Vacuum Electromagnetic Zero-Point Energy. Physical Review A, Volume 40, pages 4857 to 4862. Barrett, T.W., 1991. Tesla's Nonlinear Oscillator Shuttle Circuit, OSC Theory. Annales de la Fondation, Louis de Broglie, Volume 16, Number 1, pages 23 to 41. Barrett shows that a higher topology EM model, e.g., EM expressed in quaternions, allows shuttling and storage of potentials in circuits, and also allows additional EM functioning of a circuit that a conventional EM analysis cannot reveal. As an example, one may meet optical functioning without the presence of optical materials. Jackson, J.D., 1975. Classical Electrodynamics, 2nd edition, John Wiley & Sons, New York, page 13 to 17. Jackson, page 17. Barris, Carl, 1898. A Curious Inversion in the Wave Mechanism of the Electromagnetic Theory of Light. American Journal of Science, Volume 5, 4th Series, page 343 to 348. This is the first known solution of Maxwell's equations for a time-reversed EM wave. With the blossoming of nonlinear phase conjugate optics in the 70s, the production and utilization of the phase conjugate, time-reversed, EM wave became commonplace at optical frequencies. However, the time-reversed wave is a general solution to the wave equation and theoretically applies to any kind of wave, regardless of type or frequency.